Good morning friends. We will see scalar product of the vectors. As the name implies that the resultant of the scalar product is getting only magnitude. It is a scalar. See here, we know that A dot B can be written as vector A modulus dot vector B modulus into cos theta. This is very important thing wherever we have to just deal with the magnitude problems. See, just one example I am taking. This vector A is I cap plus j cap, vector B is 2i minus 3j. So we can easily find its dot product, that is, and you will see that its magnitude is coming out to be scalar. See how? This is vector I cap j cap dot 2i cap minus 3j cap. So what it is coming out to be, it is 2i dot I is 1 plus I into 3j. So it is coming out to be minus 3 I dot j is 0 plus j with I is 0, so 2 dot 0 minus 3 dot 1. So you can easily find magnitude. What you have to remember, that I dot I is always 1. See how it is coming out to be. When we have to find I dot I, according to the formula, it should be magnitude of I, that should be 1 dot 1 cos theta, and angle between vector I cap and vector I cap is 0 degree. So it is coming out to be cos 0 degree. So it is cos 0, we know that it is 1. So 1. So always remember that I dot I is 1, j dot j is 1, k cap dot k cap is 1. Very easy. And wherever you have to find dissimilar unit vectors, I dot j, if I have to go for it, what is that? Magnitude of I is 1, of course. That of j cap is also 1, because these are unit vectors, and angle between them is 90 degree, because this is unit vector along x-axis and this is unit vector along y-axis. So what we know, that cos 90 is 0, so 1 into 0 is actually 0. So what result you are getting is that if we multiply a unit vector with itself, the magnitude is 1. If we multiply a unit vector with dissimilar unit vector, the magnitude is 0. One more important result we should see, that if we just go for vector A dot vector A, what it is coming out to be? Vector A dot vector A is actually magnitude of A dot magnitude of vector A, and the angle between vector A and vector A is 0 degree. So cos 0 is 1. So what result we are getting? That modulus of A square. So what we know, that vector A whole square is equal to modulus of vector A whole square. That we will be using in certain type of problem. Suppose we have to find, sometime we will see that what is the magnitude of this, okay, and nothing is given, some relation is given that A and B are at an angle of 90 degree, B and C at 90 degree, or so something is given. So the thing what we are getting for is movement is that we know that the whole square of this is giving us vector A plus vector B plus vector C dot the same thing. Now we got the movement. We can now just find whatever unknown thing is there. So what we have learned? We have learned this thing. We have learned that magnitude of a vector square is equal to that vector dot that vector. That is very important. Two things you have to remember. So we have learned that if two vectors are parallel, they are in the fashion vector A is equal to lambda into vector B. That means if two vectors are in such a fashion that one vector is scalar multiple of another vector, that means these vectors are parallel. So wherever you have to take any vector parallel to a given vector, take in this fashion. This is another thing we are learning. Now we will see the projection of a vector along another vector. Now see what is happening actually in dot product. Suppose this is vector A, this is vector B, and this is, angle between them. What is this? Can you tell me? This is projection of B along vector A. Why? This is B cos theta. How this is coming B cos theta? You can easily see that if you just write cos theta, what it will be? That will be base divided by hypotenuse. Base is A by hypotenuse is what? Hypotenuse is B. Suppose A is the magnitude of vector A, B is the magnitude of vector B. Okay, if I write in this fashion, not a problem at all. So what is that? You see that. So you have seen that projection of vector B along vector A is B cos theta. So we will see how we can find the projection of vector along any vector to which it is inclined to some angle. See here, what is B cos theta? B cos theta means projection of vector B along in the direction of vector A. This is very important thing. Now see, we can get B cos theta from the formula as B cos theta is equal to A dot B divided by magnitude of A. So very important and very easy formula. You can see, if you have to find projection of a vector along any vector, what you have to do, you just find their dot product divided by the magnitude of the vector along which we have to find the projection. Suppose P and Q are two vectors, okay, and we have to find the projection of P along Q. We have derived the formula. Projection of P is coming out to be projection of P along vector Q is coming out to be what I said, their dot product P dot Q divided by along which we are finding the magnitude. We are finding along vector Q, so this is. So easily you can find the projection of a vector along another vector. Now see, we are going to solve a particular problem making the application of the concept we have learned. What concept we have learned? That we can easily find the angle between two vectors as A dot B is equal to AB cos theta. So we can easily find angle between them. And furthermore, we have learned that if we have to prove two vectors to be perpendicular, then their dot product should be 0. Why? Because then cos 90 is going to give you 0. So to prove the two vectors to be perpendicular, we have to prove their dot product to be 0. Very important result we are seeing here. Now see, in this particular problem, vector A is this, vector B is that. Express B as B1 plus B2, where B1 is parallel to vector A. What we have learned, that if a given vector is parallel to another vector, that vector is equal to lambda times the vector to which it is parallel. So we can write vector B1 is equal to lambda times is parallel to vector A. So it is going to be lambda times vector A is 3i minus j cap. So it is coming out to be 3 lambda I cap minus lambda j cap. We got vector B1, it is B1. Okay, so B1 is parallel to vector A, so we got the value of B1. You know, vector B is equal to B1 plus B2. So we got the value of B1, we can get B2 because B is B1 plus B2. So we will write it 2i cap plus j cap minus 3k cap is vector B is equal to B1, that is 3 lambda I minus lambda j cap plus B2 vector. So B2 we can easily get. So vector B2 is 2 minus 3 lambda I cap plus 1 plus lambda j cap minus 3 k cap. So we got B2. Now the thing is given that V2 is perpendicular to vector A, and we know that if two vectors are perpendicular, their dot product is 0. So it will be in the fashion vector A dot vector B2 is equal to 0. That is implying that vector A is 3i cap minus j cap dot vector B2, we got it here, 2 minus 3 lambda I cap plus 1 plus lambda j cap minus 3 k cap. So on multiplying, it is going to give you, as it has to come out to be 0, this if I multiply, better to put it in the bracket, I think with the I is going to give you 6 minus 9 lambda, j thing to the j thing is going to give you 1 plus lambda with minus sign here because minus a cap is there, is 0. So it is actually 5 minus 10 lambda is equal to 0. So lambda is equal to 1 by 2. Once we got the value of lambda, we can easily find B1 by putting the value of lambda here and B2 also by putting the value of lambda here. So easily we can get the value of B1 and B2 by just applying the basic thing we learnt in the dot product of the vectors. Hope you are understanding. Thank you.
For useful videos, log on to my channel Santosh Pembi on YouTube or directly go to my website www.mathsonphone.com. Thank you.